Hello, everybody, and welcome. I am Mr. Folly. Oops, but I am not running. I am Mr. Folly. Let's go blue. And welcome to 11.2 pH math. So this is where we are just looking at a little calculator work. We're going to give you the equations. You're going to have to do a calculator dance, and that's about it. So pH and pOH. H positive equals the concentration of a strong acid only for strong acids. So I know my good little soldiers out here already memorized the 6 strong acids, which are HCl, HBr, HI, HNO3, H2SO4, and HClO4. And if you're not one of those acids, you're nothing. You're a weak acid and an embarrassment to all of your other acid friends and family. So you got to be one of those 6 for it, okay? No Ka would be given, or if K was given, it would be called large, and we'll do Ka next time. We're going to give a logarithmic representation of H positive and OH negative. So what's weird about pH, and you know pH measures acidity, is you learned today in class that stomach acid has a pH of 1. That's 0.1. But I forgot what was 6. Anyone remember what was 6? What had a pH of 6? Blood? Milk. Milk had a pH of 6, and that was 1, 2, 3, 4, 5, 6 molar. So notice how it's not 6 times, it's, what is that, 100,000 times, 60 times less acidic. So because the scale goes by a power of 10, the little p in pH stands for power of 10. Okay, so this stands for power of 10 of the H positive, and that's it. Okay, so pH equals negative log of H positive. Remember, brackets means it has to be in molarity, and it will always be in molarity. Gee, it's like I knew I should say that. It says that right there. pOH equals negative log of OH. So notice, what does little p mean? Negative log of it, right? So if I asked you for pKa, that would be negative log of Ka. Or if I said P, your mom, that would be negative log your mom. Okay, so that's what that P means. All right. Now, the contrast to that is when we're looking for the ions. H positive is 10 to the negative pH, right? OH negative is 10 to the negative POH. Oh. Now, if you remember your Algebra 2 math with logs and anti-logs and all that stuff, this is like, oh, please, you shouldn't give me more than one equation. Yeah, but we do. We don't trust you to remember your logs very well. The next equation is pH plus pOH equals 14. Remember how our pH is balanced from 0 to 14, so this kind of makes sense. And then H positive plus OH negative equals 1E negative 14. I don't use that one as much. I tend to use this guy because I don't like to use scientific notation as much. All right, so let's do it. Find the pH of the following. So this right here is 0.1 molar of HCl. This says, hello, I'm an acid. And is HCl a strong acid? Yes, it is. It's one of my 6 strong ones, HCl. So that means, to find the pH, pH equals negative log of H positive. So pH equals negative log of 0.1. So the pH of this is 1. If you put in your calculator negative log of 0.1, you get 1. Remember, the log part says basically how many zeros over are you. And if the number is 1, it's pretty easy to do. Okay? The next one, if I'm doing 0.350 molar H positive, pH equals negative log of H positive equals negative log of 0.35 equals, reaching for my calculator because I can't do that one in my head, negative log 0.35, enter. Oh, I got the wrong answer. It says error quit go to. And so I hit go to. Oh, I put minus log instead of negative log. I have to make sure I use negative log. And when I use negative log, I get a good answer of 0.456. Okay. pH does not have a unit. Okay. It's actually a ratio of things, and ratios don't have units. I mentioned in the last podcast, if you have double OH, you double the concentration. You do not double for acid. No double. You don't double acids. You do double bases. You don't double acids. So I'm going to just do negative log 0.125. So negative log 0.005 is 2.30. So that's not too bad. It's just basically throwing numbers in your calculator, getting comfortable with finding them. Now, some people in here are not doing these at home. And if you're not doing them at home, that means you don't know how to find the log button on your calculator. Okay. Give the H positive the following. So remember, H positive equals 10 to the negative pH. The way I like to do that is if you look at your log button, if you hit second log, that gives you 10 to the, right? So I like to do that right away. So I'm going to do 10 to the negative 2.4. So I'm going to hit second log negative 2.4. I got 0.00398. This does have a unit of molarity of H positive. So again, H positive is 10 to the negative pH. 10 to the negative 8.6 equals second log negative 8.6. Enter. Oh, man. Some of you fools will put 2.51 and you'd be wrong. You need the E negative 9. That tells you the exponent for it. Because there's a huge difference between 2.51 and 0.12345678251. These are the same number. This does not equal those. And if I do 10 to the negative 7, I put that in my calculator, I get 1 E negative 7 molar. All right. So here we go. POH. So POH, notice these will be bases for the most part. How can I tell this is a base? Oh, it ends in OH, right? So, and this is a strong base. Strong like a bull. Why? Because it is in the first two columns of the periodic table. Remember, these are the guys that are golden. So, POH is negative log of OH negative equals POH. So, negative log of 0.2, negative log 0.2 is 0.699. Now notice this time I have two OHs. You do double, yes, double bases. Remember, no double acids, but yes, double bases if there's two of them. So I'm going to do negative log of OH negative. I hope I don't blow your minds by doubling in my head. Negative log 0.006 is 2.22. This is just the hydroxide, so I don't have to think about if it's weak or strong. Negative log 2.5 E negative 4. So negative log 2.5 second comma negative 4. I wish you would have put those in your calculators as I did it for all the other ones, because I think the most missed question on the test was people didn't know how to do the scientific notation. 3.60. Okay. And then remember over here, OH negative equals 10 to the negative POH. So this is just 10 to the negative 6.1, 10 to the negative 13.2, 10 to the negative 1.75. And I get my calculator busy. Second log negative 6.1, 7.94 E negative 7. Second log negative 13.2 is 6.31 E negative 14. Negative, that's not what I'm doing. Second log negative 1.75 is 0.0178. And remember, these are molarities of OH negative, and I almost missed a point. Oh no, my pen didn't write. This was negative 14. Okay. So that's not too bad. Just throw them in there. It's just math. Find the pH acid measurement of a base. If I negative log OH negative, I don't get pH. If I negative log OH negative, I get POH. Oh, but it asks for pH. So if I can't immediately get it, the next equation I'm going to use, I'll show you that in a second. So let's find this. Negative log of 0.2 equals negative log 0.2 is 0.699 equals POH. So if I don't get the P that I want to get, then I got to switch it to the other P. pH plus POH equals 14. So I want pH, so pH equals 14 minus pH, 14 minus 0.699, 13.31. Remember when I used to, what? 14 minus 0.699, my calculator lied to me, 13.30. All right. Find the OH, that's the base part. Find the base part of a solution of 0.2 molar H positive. Okay, so because I've done so many pHs, my first thought is I'll change this to pH. Then I'll change it to POH. Then I'll change it to OH negative. And then someone in here is going like, nah. Remember H positive times OH negative equals 1E negative 14. Where did that come from? Where's that from? Oh, that's the list of equations, right? Oh, I'll use that one right there. So I have 0.2 times OH negative equals 1E negative 14. So OH negative equals 1E negative 14 divided by point dose. And I get 5E negative 14 molar. And that's all there is to it. So, in that case, we could say, what do we want to say?
Toodles.